Hello my scholars, this is my Myschool YouTube channel and my name is Frank. In today's video, we shall be answering JAMB CBT physics past question for the year 2000. So relax, do not go anywhere and we'll be right back. You are welcome back to my Myschool YouTube channel. In today's video, we shall be answering question 1 to 25. So let's start with question 1. When a ship sails from salt water into fresh water, the fraction of its volume above the water surface will A. increase, B. decrease, C. remain the same, D. increase, then decrease. Okay, so the extent to which an object sinks in a substance, okay, depends on the density of the substance, right? So salt water is denser than fresh water. Okay, so when a ship moves from salt water into fresh water, the ship is going to sink in more into the fresh water than the salt water. Okay, so option A, increase, no, it will not increase. B, it will decrease, yes, because the ship sailed from a denser substance to a less denser substance. C, it will not remain the same because the density of the two substances are not the same. D, increase, then decrease. No, it will not increase and then decrease. Okay, so that makes option B the correct answer to this question. Question 2. I, its velocity is constant. I, no work is done on the body. I, it has constant acceleration directed away from the center. IV, the centripetal force is directed towards the center. Which combination of the above is true of a body moving with constant speed in a circular track? Okay, so for a body moving with constant speed in a circular track, its velocity is constant. Okay, so the velocity is not constant, although the magnitude of the velocity will remain, but the direction of the velocity is always changing. Okay, no work is done on the body. Of course, no work is done on a body moving with constant speed in a circular path. Okay, so I is true. Then let's go to I. It has constant acceleration directed away from the center. No, for a body undergoing circular motion, the acceleration is always directed towards the center, which is not true. Then IV, the centripetal force is directed towards the center. Yes, the centripetal force is directed towards the center because the acceleration of the body undergoing circular motion is directed towards the center. Okay, so that makes I and IV the correct answer to this question, and that agrees with option A. Okay, so option A is the answer to this question, I and IV. Question 3. The velocity ratio of a machine is 5 and its efficiency is 75%. What effort will be needed to lift a load of 150 Newton with the machine? Okay, so this involves a calculation. So let's move over to the board to provide answer to this question. Okay, so let's look at, first of all, let's write our formula. So efficiency of a machine is equals to mechanical advantage all over velocity ratio. So in this question, we are told velocity ratio is equals to 5 and efficiency is equals to 75%, right? So 75% means 75 all over 100. So we can especially write efficiency to be equals to 0.75, right? Then in this question, we're also given the load, okay, which is L is equals to 150 Newton. But you must not forget that mechanical advantage is equals to load all over effort, right? So in this question, we are asked to calculate for effort. But before we can do that, we'll have to solve for mechanical advantage first. Okay, so going by our formula, efficiency is equals to mechanical advantage all over velocity ratio, right? Now, efficiency equals to 0.75. Okay, it's equals to, or you can as well just write 75 here, then here you include times 100. Okay, so the answer will still be the same, but I prefer to write 0.75. Okay, so mechanical advantage, we don't know, all over velocity ratio, which is 5. Now we just make velocity ratio the subject of formula by simply cross multiplying, so that mechanical advantage is equals to 0.75 times 5, right? And this will be equals to 3.75. Okay, so the value of our velocity ratio is equals to 3.75. Now that we have gotten our velocity ratio, now don't forget that mechanical advantage is load all over effort, and we know our loads to be equals to 150 Newton. So we can substitute here so that we can get the efficiency, right? Now here we just make efficiency the subject of formula by switching the position of the mechanical advantage and the effort, so that our effort now will be equals to load all over mechanical advantage. So let's impute the values that are given to us. So here is 150 and here will be equals to 3.75, right? So we divide, and that will be equals to 40 Newton. Okay, so the effort is equals to 40 Newton. So let's return back to the screen to pick the correct option. So remember, from our calculation we got the efforts to be equals to 40 Newton. Okay, so that makes option C the correct answer to this question, 40 Newton. Question 4. At a fixed point below a liquid surface, the pressure downwards is P1 and pressure upwards is P2. It can be deduced that A, P1 is greater than P2, B, P1 is greater than or equal to P2, C, P1 is less than P2, and D, P1 is equals to P2. So we have to answer this question according to pressure law. So according to pressure law, it says that at constant volume of a given mass of gas, pressure of that gas is directly proportional to its absolute temperature. Okay, so in this question we are told that at a fixed point below the surface of a liquid, at that point below the surface of a liquid, the temperature too is also constant. Okay, so that makes the pressure P1 to be equal to the pressure P2. So it can be deduced that P1 is equals to P2 based on pressure law. So that makes option D the correct answer to this question. Question 5. If the force and the velocity on a system are each reduced simultaneously by half, the power of the system is A, doubled, B, reduced to a quarter, C, reduced by half, D, constant. Okay, we should not forget that power, okay, is equals to work done all over time, and power is also equals to force times velocity. So in this case, we'll be assuming that the value of the force and that of the velocity are all 1, okay, initially. So if they are reduced by half, that means they will be equal to half. That is, each of them will be half. So if we multiply both of them to get the value of the power, we'll be discovered that power will be equals to 1/4. Okay, so that means that the power, since the velocity and the force is reduced by half, the power itself will be reduced by 1/4 or 1/4, okay, of its original size. So that makes option B the correct answer to this question. Okay, so the power will be reduced to a quarter of its original size. Question 6. A catapult used to hold a stone of mass 500 grams is extended by 20 centimeters with an applied force F. If the stone leaps with a velocity of 40 meters per second, the value of F is... So let's move over to the board to solve this. Okay, but from this question, we discovered that a catapult was used to hold a stone of mass 500 grams and is extended by 20 centimeters with an applied force. So if the stone leaps with a velocity of 40 meters, okay, so here we can say that the work done on the stone, okay, is equals to the kinetic energy gained by the stone on leaving the catapult. Okay, so here we can say work done is equals to kinetic energy, KE. Right, and we know that work done is equals to force times distance, and our kinetic energy is equals to mass 1/2 times mass times velocity square. Okay, so in this question we are asked to calculate F. We are asked to calculate F, and our D is the extension, which is 20 centimeters. But of course we have to convert this to meter, right? So to convert this to meter, we simply divide by 100. So if we divide by 100, we're having 0.2 meter, right? And the mass was given to us to be equals to 500 grams. So I want to convert it to kg. So if we divide this by 1000, remember 1 kg is equals to 1000 grams. So we have to divide 500 grams by 1000 to get the value of the mass in kilogram, right? So if we divide by 1000, we're having 0.5 kg. So now that we've gotten these values, we just substitute them into the given equation. Now since we are looking for F, we just say F is equals to 1/2 m times v squared divided by D, right? And our d is 0.2. So we just substitute to get our answer. 1/2 times 0.5 times our velocity was given to us to be equal to 40 meters per second. So we put it here, 40 squared, then divided by 0.2. Okay, so 1/2 times 0.5 is also equal to 1/2, then times 40 times 40 will be 1,600 divided by 1, right? Equals to 1,600, then divided by 0.2. Okay, so this is 2 here, will give us 800, and 2 here again will give us 400, right? So we are now having 400 over 0.2. But remember that 0.2 is the same thing as 1/5, right? So to get the value of this question, okay, let's just write it out. 400 over 1, then divided by, so in this case we have to change. Okay, so this will be times 5 all over 1. So that at the end of the day we'll be having 400 times 5. Okay, so 5 times 4 is 20, then the 2 zeros. Okay, so that the force is equals to, okay, then 2 zeros, so that the force is equals to 2000 Newton. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, so the value of F that we got from our calculation is equals to 2000 Newton. But if you check the options were given to us or were written in standard form. Of course, you can always do that. So if we put that 2000 in standard form, that will be equals to 2.0 times 10 raised to power 3, which agrees with option B. Question 7. A stream is flowing at 0.75 meters per second, and a boat heading perpendicular to the stream landed at the opposite bank at an angle of 30 degrees. Calculate the velocity of the boat. So let's return back to the board to provide answer to this question. So this is the direction of the stream. Okay, this is the direction of flow of the stream, which is 0.75 meters per second, right? So a ship was supposed to come this way, but end up moving like this, okay, at angle 30. So let's call here the velocity of the boat, right? So in this question, we are asked to calculate the velocity of the boat. So we are asked to calculate VB, okay, which is the velocity of the boat. So in this case, we just apply simple trigonometric ratio, right? So we know the opposite and we are looking for the hypotenuse. So in that case, we'll be using sine. So let's say sine theta is opposite all over hypotenuse. So our theta is equal to 30 degrees, while the opposite is 0.75. Then our hypotenuse is the velocity of the boat, which is VB, right? Since we are looking for the VB, which is the velocity of the boat, we can make it the subject of the formula by simply switching position with sine 30, okay? But remember that sine 30 equals to 0.5. So that VB is equals to 0.75 divided by 0.5, right? So if we divide 0.75 by 0.5, that will be equals to 1.5 meter per second. Okay, so the velocity of the boat is equals to 1.5 meter per second. So let's return back to the board to pick the option that agrees with the answer that we got from our calculation, and that is option A, 1.50 meter per second. Question 8. A rope is being used to pull a mass of 10 kg vertically upward. Determine the tension in the rope if, starting from rest, the mass acquires a velocity of 4 meters per second in 8 seconds. Take acceleration due to gravity to be equal to 10 meters per second square. So let's move over to the board to solve this question. So the tension in the rope will be equal to mg plus ma, right? And the reason for that is because the tension, okay, the rope is actually used to pull a mass of 10 kg upward, right? So we are given acceleration due to gravity to be equal to 10 meters per second square. Then we are given acceleration to be equal to, okay, in this question acceleration is not given to us, but we are given initial velocity to be equal to 0. We are given final velocity to be equal to 4 meters per second, right? So from here we need to get the value of A. But remember that acceleration is equal to change in velocity all over time. right? Acceleration is equals to change in velocity all over time. So we can actually calculate to get the value of acceleration. So A is equals to V minus U all over T. Okay, so A is equals to, of course, our initial velocity. So here we'll be having 4 minus our initial velocity is 0 all over the time that is given to us to be equals to 8 seconds, right? So that A is equals to 4 divided by 8, and this will be 1 over 2, right? And 1 over 2 is equals to 0.5 meter per second square. Okay, so our acceleration is equals to 0.5 meter per second square, right? So if you check very well, m is common to both terms, so we can factor out m, so that tension is equals to m bracket open g plus a, right? But remember that from our calculation, our acceleration is equals to 0.5, and our g, which is acceleration due to gravity, is equals to 10, and our mass, according to the question, is equals to 10. Yeah, I didn't write that out. So equals to 10 kg, right? So we can just substitute to know the value of the tension in the rope. So m is 10, then g is 10, then plus 0.5. So 10 plus 0.5 is 10 plus 0.5 is 10.5, right? So 10.5 times 10, that will be equals to 105 Newton. Okay, so tension and force, they are the same. Okay, so tension is equals to 105 Newton. So let's return back to the board to pick the option that agrees with our calculation. Okay, and that is option D, 105 Newton. Question 9. I, the frictional force, is independent of the area of the surfaces in contact. II, the frictional force, depends on the nature of the surfaces in contact. III, the frictional force, depends on the speed of sliding. IV, the frictional force, is directly proportional to the normal reaction. Which combination of the above is true of sliding friction? So this question is basically testing our knowledge of solid friction, right, of the laws of solid friction. So number 1, the frictional force is independent of the area of the surfaces in contact is true. Okay, frictional force is independent, okay, of the area of the surfaces in contact. Okay, so I is true. Then II, the frictional force, depends on the nature of the surfaces in contact. Yes. Then III, the frictional force, depends on the speed of sliding. Okay, so according to the law of solid friction, frictional force does not depend on the speed of sliding. Okay, so III is not true. While IV, the frictional force, is directly proportional to the normal reaction, which is very true of solid friction. The frictional force is directly proportional to the normal reaction. Okay, so the combination that is true of sliding friction are 1, then II and IV. So let's go through the option if we can see the option that agrees with what we chose. So A is I, then II and IV, no. B is I, then II and IV, which agrees with our analysis. Okay, so that makes option B the correct answer to this question. C and D are not correct, just like A. Okay, so that makes option B the correct answer to this question. Do you know you can take practice question with our JAMB simulated past questions? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you have to download the Myschool application for your Android devices and Myschool software for your laptops and computers. Please go ahead and start practicing. Moving on to question 10. Total internal reflection occurs when light moves from A dense medium to a less dense medium, B, from air to water, C, water to glass, D, a less dense to a dense medium. So basically this question, I think they are trying to test our knowledge of the conditions, okay, necessary for total internal reflection to occur. Okay, so one of the conditions for total internal reflection to occur is that the light, okay, must be moving from a dense medium to a less dense medium. Okay, so that makes option A the correct answer to this question. Then option B, we are having air to water. No, water is denser than air, so in this case total internal reflection will not occur. Then C, the same to almost the same as B, glass is denser than water, so total internal reflection will not occur. Then D, a less dense to a denser medium. So basically, B, C, D are basically saying the same thing. Okay, so one of the conditions necessary for total internal reflection to occur is that the light must be moving from a dense medium to a less dense medium. So option A is the correct answer to this question. I believe you are enjoying this content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, put on the notification bell to get informed as soon as we upload the next videos. Question 11. A quantity of water at 0 degrees Celsius is heated to about 30 degrees Celsius. At each degree rise in temperature, its density will A. Rise steadily, B. Fall steadily, C. Fall, then rise, D. Rise, then fall. So this question is a question to test our knowledge of anomalous expansion of water. And you know what happens when water is heated from 0 degree to 4 degrees Celsius. Okay, so what happens is that at that temperature range, the water would contract, okay, causing the density to increase gradually, okay, until it gets to 4 degrees Celsius, where water has its maximum density. So once water is heated above 4 degrees Celsius, the density will start falling. Okay, so that makes option D the correct answer to this question. The density will rise until it gets to 4 degrees Celsius, where it has its maximum density, and then start falling once the temperature exceeds 4 degrees Celsius. Question 12. I, coherence, II, same frequency, III, same wavelength, IV, same intensity. Which of the conditions above are necessary to produce interference fringes? So what do we mean by interference? So interference is a phenomenon that occurs when the path of two waves crosses. Okay, so what are the conditions that is necessary to produce interference? One of them is coherence, then same frequency, same wavelength, and not necessary intensity. Okay, so that makes I, and I correct. Okay, so that gives us, that makes option C the correct answer to this question. I, and I. Question 13. A boy observes a piece of stone at the bottom of a river 6.0 meter deep. If he looks from the surface of the river, what is the apparent distance of the stone from him? Refractive index of water is equal to 4/3. So let's move over to the board to calculate the apparent distance of the stone from the boy. Okay, so refractive index in this case is equal to real depth over apparent depth. Okay, refractive index is equal to real depth all over apparent depth. So in this question, we know the real depth to be equal to 6.0 meter, which is the actual depth of the river. So now we are asked to calculate the apparent depth. But in this question, we are asked to take refractive index to be equal to 4/3. Okay, so you'll be having 4/3 is equal to 6, then divided by apparent depth. So let's just use AD, okay, for apparent depth. Now we are looking for apparent depth, which is AD. We simply cross multiply. So that we're having 4 AD, okay, is equals to 3 times 6, which is equals to 18, right? So AD, which is apparent depth, will now be 18 divided by 4, okay? And that will be equals to, how many 4 is in this? That is 4, then remainder 2, so 4.5 meter, okay? So the apparent depth of the stone, okay, the apparent depth of the stone from the boy is equals to 4.5 meters. Okay, so let's return back to the screen to pick the correct answer to that question. So A is 8.0 meter, B is 5.5 meter, which is not what we got from our calculation. C is 5.0 meter, and D is 4.5 meter, which agrees with our calculation. So that makes option D the correct answer to this question. Question 14. A thin wire with heavy weights attached to both ends is hung over a block of ice resting on 2 supports. If the wire cuts through the ice block while the block remains solid behind the wire, the process is called dash A, condensation. Okay, so condensation is just the process of converting vapor into water, right? Like the process whereby vapor turns into water. While B, we have sublimation. So sublimation is the process whereby a solid moves or changes to the gaseous space directly without having to pass through the intermediate liquid phase. Then C is regelation. So regelation is just a process used to demonstrate the effect of pressure on metal height. Okay, and what is described above is actually called regelation, while D means fusion, bringing two things together to become one, right? So the answer to this question is option C, regelation. Okay, so a thin wire with heavy weights attached to both ends is hung over a piece of block resting on two supports, right? So the wire will cut through the ice block while the block remains solid behind the wire. Okay, so this process is what is referred to as regelation. So that makes option C the correct answer to this question. Question 15. The reading above are for 3 consecutive days from a wet and dry bulb hygrometer. It can be concluded that the relative density for the 3 days: A, decreased steadily, B, remained unchanged, C, increased steadily, and D, was least on day 1. Okay, so basically to answer this question, it will be vital for us to know the difference between the temperature for the dry day and the wet day, right? So this is 30 degrees Celsius minus 22 degrees Celsius, and that will be equals to 8 degrees Celsius. So you'll be having 8 degrees Celsius, and you'll be having 7 degrees Celsius, and you'll be having 4 degrees Celsius. So you can see that the temperature is actually decreasing each day. Okay, but remember that relative humidity is inversely proportional to temperature. Okay, meaning that as temperature is increasing, then relative humidity will be decreasing, and as relative humidity is decreasing, okay, temperature will be increasing. So from the difference, you see that here is 8 degrees Celsius, here is 7 degrees Celsius, and here is 4 degrees Celsius. So you can observe that the temperature is actually decreasing. So in that case, the relative humidity will be increasing steadily, although the difference between here and here is far much, right? But there's actually increase in the relative humidity because the temperature is actually decreasing. Okay, remember that I said relative humidity is inversely proportional to temperature. Okay, so A decreases steadily. No, will not decrease steadily. The relative humidity will not decrease steadily because the temperature is actually decreasing steadily. Okay, then B, remain unchanged. No, there's actually change in the temperature. C, increase steadily. Yes, because the temperature is decreasing and relative humidity is inversely proportional to temperature. So as temperature is decreasing, then relative humidity will be increasing. D, was least on day 1. No, it was not least on day 1. Okay, so that makes option C the correct answer to this question. Question 16. One end of a long wire is fixed while a vibrator is attached to the other end. When the vibrator is energized, the types of waves generated in the wire are A, stationary and longitudinal, B, stationary and transverse, C, progressive and transverse, D, progressive and longitudinal. Okay, so the answer to this question is B, stationary and transverse. So when one end of a wire is fixed, okay, so that tells us about a stationary wave. So a stationary wave does not move from one point to another. Okay, so that makes one type of wave in the wire to be stationary wave, okay, and not progressive wave. So for a progressive wave, the wave moves from one point to another. Okay, when the vibrator is energized, the type of wave, so when the vibration is energized, the vibrator causes the wire to move up and down. Okay, so that the displacement of the particles of the wire is perpendicular to the direction of the wave, okay, that is traveling along the length of the wire. Okay, and that defines transverse wave. Okay, so in transverse wave, the direction of the wave is perpendicular to the displacement of the particles, while for longitudinal wave, the direction of the wave is parallel to the displacement of the particles. Okay, so that makes option B the correct answer to this question. Question 17. A metal of mass 0.5 kilogram is heated to 100 degrees Celsius and then transferred to a well-lagged calorimeter of heat capacity 80 joule per Kelvin containing water of heat capacity 420 joule per Kelvin at 15 degrees Celsius. If the final steady temperature of the mixture is 25 degrees Celsius, Find the specific heat capacity of the metal. So let's move over to the board to provide answer to this question. So these are the information that are given to us in the question. Okay, so we have to write it out first to save time. Okay, so the heat loss by metal will be equals to heat gained by calorimeter plus that gained by water. Okay, but remember that quantity of heat is equals to m times Cx times change in temperature. So Cx here stands for specific heat capacity. So for the metal, m will be, okay, so for the metal, the quantity of heat will be m, okay, times Cx, which is the specific heat capacity of the metal, then times the change in temperature, right? But remember that mass, okay, which is m times specific heat capacity, is equals to heat capacity. So remember, for calorimeter and water, the specific heat capacity and the mass is not given, but the heat capacity is given. Okay, so the quantity of heat is equals to heat capacity, then times change in temperature. So that is what we are going to be using here. Okay, so this will be equals to Cp, then change in temperature, plus Cp change in temperature. This stands for that of the calorimeter, and this stands for that of water. So let's substitute the value that are given to us. So you'll be having 0.5 times Cx, then times the change in temperature, which is 100 minus 25, which is the final temperature, will be equals to, here will be 80 times the change in temperature, which is 25 minus 15, then plus, here is the heat capacity of water, which is 420, then times change in temperature, which is 25 minus 15. Okay, so this will become 0.5 times Cx times 75, and here will be 80 times 10, then plus 420 times 10. Okay, so if we multiply these two together, we'll be having 37.5 Cx, which will be equals to 800 plus 4,200. So if we add these two together, that will be equals to 5,000. Right, now since we are looking for Cs, so we simply divide both sides by 37.5, so that Cs, which is the specific heat capacity of the metal, is equals to 5,000 divided by 37.5, and this will be equals to 133.33 continuously joule per kilogram per Kelvin, right? So, but if you check our option correctly, you discover that this part is not involved. And take note, this is not up to 5. So 3 here is not up to 5. So if we round it, we are going to round it down. So this makes our answer to be equal to, or approximately equal to 133, okay? 133 joule per Kelvin, sorry, per kilogram per Kelvin. Okay, so let's return back to the screen to pick the correct answer. So based on our calculation, we got the specific heat capacity of the metal to be equals to 133 joules per kilogram per Kelvin. Okay, and that makes option C the correct answer to this question. Question 18. The main reason for making the cover of a vacuum flask airtight is to prevent heat loss by A, convection, B, conduction, C, radiation, D, evaporation. So A, B, C are all mode of heat transfer. Okay, so for A, convection, I think the answer to this question is option A, convection. Convection is a mode of heat transfer that actually involves the transfer of heat in a fluid by the actual movement, okay, by the actual movement of the heated particles, right? So the answer to this question is option A, like I said earlier on. And the reason why vacuum flask is airtight is so that the actual movement of the heated molecules can be prevented, okay, in order to conserve heat. So that makes option A the correct answer to this question, while option B is not the correct answer to this question because this involves the transfer of heat along a solid. Why C is radiation. In radiation, there's no material medium required in the transfer of heat. Why D is simply the escape of the molecules of a substance from its surface. Okay, so that makes option A the correct answer to this question, convection. Question 19. A radio is operated by 8 cells, each of EMF 2.0 volts, connected in series. If 2 of the cells are wrongly connected, the net EMF of the radio is. So let's move over to the board to provide answer to this question. So when cells are connected in series, what happens is that their voltage actually adds up. Okay, so in this case we have 8 cells, each of EMF 2.0 volt. So since they are connected in series, the 8 cells is going to have total EMF, okay, total EMF equal to 8 times 2, right? Since the EMF of each of the cell is 2.0 volts, okay, and there are 8 of them. So the total EMF will be equals to 16 volts, right? But in the question, we are told that 2 were connected wrongly. Okay, so to actually get the net EMF of the radio, it will be the total minus those 2 that are connected wrongly. Okay, so the total of those 2 that are connected wrongly will be equals to 2 times 2. That will be equals to 4 volts, right? So to get the net EMF, okay, now will be equals to 16 minus 4, and this will be equals to 12 volts. Okay, so the net EMF of the radio is equals to 12 volts. So let's return back to the screen to pick the correct answer to this question. So A is 8 volts, B is 10 volts, and C is 12 volts, okay, which agrees with our calculation, while D is 16 volts. Okay, so the answer to this is 12 volts, C. Do you have any question? If yes, you can click on the link in the description below, and that will take you to my school website. There you can ask all your questions and solution will be provided within a short period of time. Moving on to question 20. If a charged ion goes through combined electrical and magnetic field, the resultant emergent velocity of the ion is... So let's quickly go to the board to provide answer to this question. So for a charged ion to go through a combined electrical and magnetic field, okay, the electric force must be equal to the magnetic force, okay, and the electric force is equal to QE, and that is also equal to, this is the electric force, which is Q times E, which is equal to Q, then VB for magnetic force. Okay, where Q and Q stand for quantity of charges, E here is electric field intensity, while B here is the magnetic field intensity. Okay, so these two will cancel out. Now, then remember that the V here stands for velocity. So we are actually looking to make V the subject of formula, so that V will be equals to E all over B. Okay, so let's return back to the screen to pick the correct option to this question. So from what we did on the board, the correct answer to this question is option A, E over B. Okay, and this is only true, okay, when the charged ion goes through combined electrical and magnetic field without deflection. Do you have better explanation or step to any of this question? If yes, you can go to the comment section below to comment the question number and the solution you wish to share. Question 21. A projection lantern is used to give the image of a slide on a screen. If the image is 24 times as large as the slide and the screen is 72.0 meters from the projecting lenses, what is the position of the slide from the lenses? So let's move over to the board to solve this question. So this is a question on magnification. Okay, so from the question, we can see that M is equals to 24, okay, and V is equals to 72. Then we are asked to solve for U, okay, which is the object distance. So this is image distance and this is magnification. So magnification is equals to image distance V all over object distance, or you can say image height all over object height, right? So let's put in the value that are given to us. Here we have 24, which is equals to, here is 72, then over U, but we are looking for U, so we just switch position. Okay, so U becomes 72 divided by 24, and this will be equals to 3.0 meter. Okay, so let's return back to the screen to pick the correct answer to this question. So A we have 0.3 meter, B we have 3.0 meter, C will have 3.5 meter, and D will have 4.0 meter. So the option that agrees with our calculation is option B, 3.0 meters. Question 22. An electron of charge 1.6 times 10 raised to power minus 19 coulomb and mass 9.1 times 10 raised to the power minus 31 kg is accelerated between two metal plates with a velocity of 4 times 10 raised to the power 7 meter per second. The potential difference between the plates is, so let's move over to the board to solve this question. So in this question, an electron was accelerated, right? So in that case, the electron undergo kinetic energy. So that will be because 1/2 times mass times velocity square for kinetic energy of the electron, right? Now, the work done in accelerating the electron between two metal plates will be equals to W is equals to Q times potential difference V. Okay, so in this question, we are asked to calculate potential difference. So in that case, we are going to be equating the work done, okay, and the kinetic energy of the electron. So here we're having Q times V is equals to 1/2, then mass times velocity square. Okay, so in this question, we are given velocity, we are given mass, and we are given the quantity of charge for us to look for V. So let's make V the subject of formula, so that V will be equals to 1/2 times M times V square divided by Q. Okay, so let's just impute the values that are given to us. So 1/2 times mass, which is 9.1 times 10 raised to the power minus 31, then times, in bracket, 4 times 10 raised to the power 7 square divided by 1.6 times 10 raised to the power minus 19. Okay, so if we divide, we'll be having 4,550 volts, okay, for the value of the potential difference. Okay, so if we put this in standard form, we'll be having 4.55 times 10 raised to the power 3 volts. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, so from our calculation, we got 4.55 times 10 raised to the power 3 volts. So that agrees with option A, 4.55 times 10 raised to the power 3 volts. Question 23. A cell of internal resistance 0.01 ohm can be measured accurately using the A ohm meter. So ohm meter is used to measure electrical resistance. Okay, so the answer cannot be A. B, meter bridge. So meter bridge is used to measure the unknown resistor, okay, in a coil. While C, we have potentiometer. So the answer to this question is actually potentiometer. So potentiometer is used to measure, to regulate, first of all, to regulate EMF and also the internal resistance of a component. Okay, and the potentiometer can measure the internal resistance of a component without taking current, okay, from the component. While option D is a device used to detect charge. So the answer to this question is potentiometer. Question 24. What optical instrument can best be constructed with converging lenses of focal length 50 centimeter and 5 centimeters? So we have the compound microscope. So the compound microscope consists of two converging lenses. You have the objective and the eyepiece. Then B, we have the Galileo's telescope. So the Galileo telescope is actually used to view objects here on Earth. And another name for the Galileo telescope is the terrestrial telescope. So that makes option B and C actually saying the same thing. Okay, while option D, we have the astronomical telescope. So the astronomical telescope consists of two converging lenses, with the objective lens much longer than the eyepiece. Okay, so the astronomical telescope agrees with what is described above. Okay, so that makes option D the answer to this question. Question 25. In a pure semiconductor, the number of electrons in the conduction band is A, less than the number of holes in the valence band, B, equal to the number of holes in the valence band. Okay, so the answer to this question is option B. Now, another word for pure semiconductor is intrinsic semiconductor. So more or less like, say, the natural form in which a semiconductor occurs. So in a pure semiconductor, the number of electrons in the conduction band is equal to the number of holes in the valence band, right? So that makes option B the correct answer to this question. So let's see option C, greater than the number of holes in the valence band. No, that is not possible, because pure semiconductor is also known as intrinsic semiconductor. There, the number of holes is equal to the number of electrons. Why B? Twice the number of holes in the valence band? No. So the answer to this question is option B. Okay, so the number of electrons in the conduction band is equal to the number of holes in the valence band. I believe you are enjoying this content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly tap on the notification bell to get notified as soon as we upload the next video.